Hi, everyone. I'm Kiran. This is Michael. We're developer advocates. Before I say anything, I want to demonstrate, and action speaks louder than words, or so I've been told. So I'm just going to demonstrate what we're going to be building today. So here I have a contract, a simple contract. Again, we can look at the code later, but for now, what I'll do is I'm going to pay special attention to this contract address, ends with 37E. What we're going to do, I'm going to go to calls and see all these different transactions. You see, we have these transactions occurring every 15 seconds or so, and we're going to see one in a little bit here. But if we go to Events tab, we see, okay, every time, every transaction is printing hello Hedera every 15 seconds. And if we look at any one of the transaction, let's dive into it a little bit here, right? Let me open another one. Okay, so here, well, let's just go to the events. That's fine. So you might be wondering, well, why are these events being printed every 15 seconds? Trust me, I don't have a person somewhere executing these transactions. These are actually happening in real time. What's happening is every 15 seconds, the protocol itself is waking up our smart contract and calling a specific function and then printing the message, in this case, emitting an event. And you might be wondering, well, how is this happening? Right? We don't have any off-chain infrastructure, off-chain bot server. There's no Chainlink Keeper, Gelato, like none of this. It's all happening on-chain. It's the protocol doing it. And today, we're going to be deploying the exact same contract. We're going to do it live, and hopefully all of you can also do it live with me, because it's quite easy to get started here. Let me go back to slides. All right. So the agenda for today, first I showed the cron job that was happening on-chain. These transactions were happening every 15 seconds automatically, and we're going to talk about what exactly enables that on something like Hedera. Like, you don't see this on other EVM chains like Ethereum or Base or anything else. You need to use this off-chain infrastructure. And we're going to talk about Hedera scheduled service. And then after that, we have a hands-on exercise. We're going to be deploying the contract. And then we're going to talk about some use cases that this specific scheduled service enables. And then some of the next steps. All right, first of all, when we talk about any kind of smart contracts, they all have an automation problem, right? Smart contracts, like we've heard this term smart contracts since 2015, but can we really say they are smart in the traditional sense? Because if you think about it, a smart contract, all it does, it sits on-chain, it doesn't do anything by itself. Someone manually has to poke at it by sending a transaction, and then it executes it, right? There's no, like, if the transaction is not executed, if the transaction is not triggered, then it's not executed. It's as simple as that. And it's almost like when you have all these kind of things happening, like some of the times when you're dealing with time-based capabilities you want to introduce on your contracts, you have to rely on some off-chain infrastructure. We talked about Chainlink Keepers, and you may even have your own cron job running somewhere that is executing these transactions every so often, every day, every week, whatever. But when we're dealing with time-based capability, right, as an example, right, if you want to rebalance a vault in a DeFi setting every hour, if you want to have a recurring payment once every 7 days for the next month or so, or for the next year, or if you have like a governance proposal that needs to be executed without you manually triggering the execution, well, it's just not possible because it's not possible at the protocol level. And that's most of the problems that we see on other EVM chains. So how do they solve it today? So what happens is you have some kind of network, like a Gelato network or OpenZetLim Defender, or you might have your own custom bot server somewhere to automate this entire process. And thousands of protocols have been using this for a long time, and it works, right? It works. But the problem is, there is still some centralization risk that comes along with it, because you're still having to trust that other third party to execute your transaction at a specific point in time. If something were to go wrong, at 3 a.m. and your DeFi vault doesn't get rebalanced, well, your users might get liquidated for no reason, right? And there's also additional cost. In addition to paying for the gas, you're also paying some sort of recurring fees to have this off-chain service. And there's also some trust assumptions. You have to trust this centralized party or out there somewhere to do the work that you want it to do. And then there's also the infrastructure overhead. Someone needs to manage that server. It's just a lot of cost associated with it, right? It works, it solves the problem, but you're still trusting someone or something to call your contract, and you're paying for it. So how do we solve that on Hedera? And I'll let Michael talk about Hedera scheduled service.
Yeah, so let's understand a little bit more about HSS and how it works. So it's a native Hedera service that allows transactions to be scheduled for future execution at the protocol level. There's no other third party involved in it, as Kiran had mentioned earlier. We schedule a transaction, Hedera stores that call data, and then at some point in the future, we have automatic execution of that wrapped transaction from the HSS, which is all really cool. But we could also do this from smart contracts as well. So we can now have smart contracts schedule themselves or other smart contracts. And that's done via HIP 1215. So HIP 1215 is a bit of a game changer for generalized scheduled contract calls, as the title states. It allows you, inside your contract, to make a schedule call to 16B. We kind of mentioned earlier was a precompile that's been added into the EVM network to allow us to talk to native services under the hood. The HSS will store the transaction that you want to call in the future, along with an expiry date and some other metadata. When that time happens in the future, the consensus node picks up the transaction from the HSS and then executes it on the consensus node. So this is all happening on the network itself. There is no third party involved. What it allows us to do, essentially, is to have on-chain cron jobs, self-perpetuating contract logic, which allows, if a contract does something and it's a successful transaction, it can then decide to call itself again and recommit, which is pretty cool. Truly, you're going to get smart contracts at that point. We get fully autonomous smart contracts and zero off-chain infrastructure, which is really cool. Gives you, less technology to manage as you go along. So, as Kiran had alluded to before, there's ways to solve this in other blockchains, and it has been solved. We have keepers, the networks, and your own servers to do this kind of work. It has a lot of external automation. You need to know DevOps. You might need to know security. You have to do a lot of key management that's kind of problematic if you don't get it right. Additional costs and multiple points of failure. Whereas the Hedera solution is a lot more elegant and simple. You have a smart contract. It's funded. It can schedule calls. They auto-execute in the future via the HSS, and it all happens inside the consensus layer. It's native. It's built in, and there's no external dependencies. Okay, if you're doing the scavenger hunt, you know what you need to do. All good? Okay, so back to Kiran, and he's going to show us now a kind of hands-on exercise on how to actually use this technology. Thanks.
Thanks, Michael. All right, thanks for the introduction to scheduled service. For the next part of the presentation, I'm going to be demoing deploying the contract. We're going to interact with the contract. We're going to look at it on the Explorer, how it looks like. When you're talking about a contract that schedules itself in the future, sort of like I try to use an analogy, it's almost like if a runner were in a relay race, the way that scheduled service works is a runner passes the baton to himself in the future across time. That's how I like to imagine it. That's basically what happens here. So I'm going to talk about the pattern to be aware of. And again, this is just a pattern, right? But it's super straightforward to understand how the mechanics work if you understand how the whole scheduling system works on Hedera. So the first thing that we need to worry about is, there's three different processes, three different stages as part of the pattern. The first is the initialization function, right? This is the function which you initially call to get the schedule started, and it will handle, things like, okay, schedule, keep repeating this schedule like 15 seconds from now, and I want you to emit an event, I want you to do something, balance, pay, whatever it is, that is part of this function, this first entry point into the scheduled service. And what's going to happen is, and then the second is the worker function. The worker function is where the magic happens, because what happens is when those 15 seconds or 30 seconds, however much time you have passed in on your cron job, passes, the consensus node, the network itself, wakes up your smart contract and then calls your smart contract with the function, with the call data that you gave it as part of the initialization function. So let me back up. So if you have on this worker function, if you may have a function that just emits an event that says, hello, Hedera, every 15 seconds. So what happens is it emits that event, and then at the end, right before it ends, it basically schedules its next execution, next execution 15 seconds from now. So, and then the loop continues forever and ever, or until your contract runs out of HBAR. So if you have a lot of HBAR in your contract, you do need to be aware of, you have this scheduler service running, and it's just going to keep running until you exhaust it, or coming back to the third stage, which is the function for stopping, because you want your scheduler to stop. Maybe like something happened, you just want to stop it midway. You can always restart it, but you also probably need to have a stop function to stop it midway. If you're running out of HBAR, you want to replenish that. Again, like if you run out of HBAR in the contract, it will just fail and it will stop the loop. So you need to restart the scheduler, but that's the pattern. All right, let's go back to the demo. I am going to open up this guide, and this should be part of the prerequisites. If not, it should be in the same repository that we're using here. Just to reiterate, it is on Hedera-dev, DevDay tutorial hello scheduled world. You can go to docs and then guide if you want to follow along with the guide. But just to keep things simple, what I'm going to do is I'm going to walk through this guide, and I'm going to show you how exactly you can deploy this contract and then interact with it and schedule and do all kinds of crazy stuff. All right, so first thing you need to have is, obviously, you need to have some testnet HBAR. So if you haven't, go to portal.hedera.com and then get some HBAR, your hex-encoded private key, start with 0x. All right, the first thing we're going to do is we're just going to create a directory first, so we can just start everything fresh. So I'm in this directory. All right, let me make it bigger. I'm just going to copy paste. So all I'm doing is creating the directory. I change it to the directory. What I'm going to do is I'm going to initialize this project with Foundry, with Forge. So it's going to initialize, we look here. You see the live directory, that's all the dependencies. And then you have the test, and then it comes with the default counter contract and test. So I'm just going to remove all that first. Let me just open this on VS Code. There we go. Just for the sake of it, I'm going to open this also in the same one. So, all right. Just to make things simpler, I'm just going to do everything on the VS Code here, so it's easier to follow along. All right. So the first thing we're going to do is we initialize our directory with Forge. That's all dandy. I'm just going to remove these files that I don't need, because I don't really need them. Again, just to make things simpler, instead of typing all this, I'm just going to copy paste. And I'll explain a little bit about all the code that I'm copying pasting. So for now, let's just copy paste. So all we're doing is we're setting our profile on Foundry. So we're going to have an environment variable later, which is going to define our RPC URL, and then this just comes with it. The remappings is more there for, because usually what happens is when you install a particular library dependency, it's under some, in this case, it's lib Hedera smart contracts. And in order to make things simpler, I want to be able to import on my contract with something like add hashgraph / smart contracts. So that's why we have the remappings here. But that's all. That's all we need for the foundry.toml file. Next, we're going to create our environment file. I already have an environment file, so I'm just going to copy that over on this directory. But you'll probably need to substitute this to your own hex-encoded private key. Next thing we're going to do is we're going to load our environment variables locally, so we can play around with it through Foundry, so through Forge. All right, so next, what we're going to do is we're going to install our smart contracts, system smart contract library directly in Foundry so that we can utilize the Hedera schedule service precompile, and that exposes a lot of the things that makes our whole smart contract self-executable, repeatable in a cron job manner. So let me just copy-paste this. So this is going to install this locally. May take some time. Next, let me talk a little bit about this. So what we have here, and this is one of the key functions, and we'll show this in the code later, but this is the core function that is going to be rescheduling. So here on the address, this is the contract that you're asking the protocol to call. So in our case, because we have this cron job that's going to execute its own function in the future, the 2 will be the address of the smart contract itself. So it's sort of the relay race analogy that I told about earlier. The expiry second is when you want to have the network call your function 15 seconds, 30 seconds, a week from now, 2 weeks from now, whatever it is, right? And the gas limit, you probably want this to be enough that whenever the smart contract calls itself in the future, you have enough gas. Otherwise, it's going to revert, so you don't want that happening. And we're going to see that. We're going to see how to set that later. And then value, usually for this use case today, it's 0. But if your function requires some kind of value, sending HBAR, you can do that. Call data is where majority of the encoding happens. So in our case, we're going to have a function that's just going to emit an event and then schedule itself in the future. So all of that is going to be encoded, and then we're going to pass it in to this schedule call function. All right, so let me copy this first, and I'll explain a little bit about the structure of this contract. There it is. All right, let me create a directory, file called hello scheduled world.sol, and then explain a little bit about this here. Make it bigger. All right. So here, let me just do this. Don't need to do that, but let's just ignore that. We don't want the linter complaining. All right, so here, first, we are importing Hedera scheduled service from our system contract library. This is the full path here, but again, you can feel free to check out, you can check out more about all the functionalities that Hedera scheduled service exposes. One of them is the schedule call that we talked about, but there are some other functions as well, you're able to have a function. We don't have that in this demo, but in the second demo, where you're able to check exactly the time slot that is going to be open to execute your call in the future. That way, whenever, you can know exactly ahead of time that your function is going to be executed at that particular time. So here I'm setting the gas limit to be 2 million. That's fine for this case because, as we know on Hedera, as of recently, no matter how much gas limit you send in, it will only consume the gas that it actually uses. So you're not going to be charged for 80% like you used to before. So that's good. It works for this. We have our constructor, and then we have our receive function. The reason is, someone has to pay for the scheduled transaction, and it's the contract paying for that. So you need this receive function so that you can send, and also constructor to be payable. So you can send some HBAR to your contract address, and then the network, when the network calls your contract later on, 15 seconds, 30 seconds, it will just reduce that amount from your contract balance. So this is the meat of the project. So this is the initialization function that I talked about earlier, which is the entry point, right? We have the message, hello Hedera earlier in our demo interval, let's say 15 seconds, but you can really go far in the future. And then this is an internal variable that is going to keep track of whether the scheduled current cron job is active. If it's false, then it's not going to execute. So, and then we have this schedule function. It's an internal function. All it's doing is, as I was talking about earlier, we have this print message function. Let's just look at that. So this is our worker function I talked about earlier on our pattern. So all it's doing is it's checking, okay, is active, is the cron job running? Like, am I supposed to run it? Okay, if it's active, then we go ahead. And then it's going to emit an event with the message that we passed in initially. And then it also includes the timestamp. So we know we can check it later when it got executed. And then the last thing that it does, remember, it needs to be able to schedule its own future call. So it just calls schedule again. So like we're re-entering here to basically encode all the message, all the data that print message requires, and then we're passing this data in to the schedule call function. Remember, I talked about schedule call function here. It takes 2 expiry second, gas limit, value, and call data. That's exactly what it's taking. So here we're passing our own contract. You can pass in another contract, that's fine. And we have the time, which is whatever we set it. Gas limit, we're passing the gas limit. 0 in this case, but it may be different for your case. Data is the actual data of the function that we're trying to execute every so often. And then last but not least, if it fails, then it's going to say schedule failed, blah, blah, blah. And that's it. Like, it is under 50 lines of code. And this is all you need to have a cron job running on chain. So the smart contract, the protocol wakes up the smart contract executes its own logic, and then the last thing it does is reschedule itself whatever time in the future that you set it. That's all it's doing, right? So let's go ahead and, let me come back here. Whoop. Let's go ahead and build our project. So Forge build. It's going to compile. So here I'm using Forge to basically deploy the contract. If you're not familiar with Forge, here all I'm saying is, OK, Forge, create or deploy this contract that is on source hello scheduled world.sol. That's the contract name. And then we're passing our RPC URL, which is set in the environment variable. And then let me just do this just in case. And then we're passing the private key because you're signing with your account. And then I'm going to send some ether. In this case, it would be HBAR, because that's just the syntax that Forge has. So ether, just remember that this is just saying 10 HBAR. And then broadcast is just used to broadcast the transaction. So let me just copy this code and deploy this contract. All right, so we have our deployer. This is our account that I'm using to deploy. This is where it got deployed. And then this is a transaction hash. We can check this really quickly here. So if I go here, here's our contract. All right, well, I can't see any bytecode here, actual source code. That's because the contract isn't verified. We're going to solve that pretty quickly here. So first thing we want to do is, and we're going to use this later, so I probably want to set this variable, contract address equals this. And then, again, this is an optional step, but if we want to see what's going on, like if we want to trace all the events, like all the data, we probably want to verify it. So this is a helper script. It's all in the documentation, but there's a helper script that generates a metadata.json file that you can just feed into Hashcan. And it works with Foundry and Hardhat both. And it's a really easy way to generate the entire metadata. It works for multiple contracts at the same time. Like, it works for all use cases. So I'm just going to copy this, and all it's doing is making this verification, the metadata generation script available so to be executed. And then I'm going to generate this. All right, now you see here, this is the metadata JSON file. So I'm going to do hello metadata. Let's do downloads. All right, I'm going to quickly verify this. All right. There it is. Got it verified quickly. Now we can look at the source code, ABI, source code here. All right, now we're ready to execute our function. So next step is, so we're using Caster. We're doing with Foundry today, so we're just going to be using all Foundry and Forge-related commands. But all this is doing is it's calling our initialization function, like scheduled message. We're passing in hello Hedera every 15 seconds. We're passing in our RPC URL, and then the private key, right? So let's go ahead and execute that. All right, got executed. We can check the calls tab here. All right, so if we look at the trace, okay, scheduled message, it got scheduled. Let's wait a little bit here, 15 seconds, and then we'll jump back when I refresh the page. There it is. Oh, wait.
Yep. Yeah, it's first one.
Okay. Let's go to trace. So this is the first call. So we see here, this is the contract address. We see here, like, this scheduled transaction got executed. Usually, these two addresses are different, right? Because someone else is calling it. But here, in this case, it's the contract for the from address, and then it's the contract itself for the to, because the contract is calling itself with however many, and it's executing this print message. That's all it's doing. And if we look back again and again, you see here, all of these are getting executed. Again, this is my account. I'm just executing locally, but every 15 seconds, we look at the events tab. We see hello Hedera, timestamp is there. Every 15 seconds, we have a working code. We can also check something here pretty quickly. So all this is doing is checking whether the cron job is active. We're calling the isActive public function of the contract. Same thing here, like what's the message, hello Hedera, and then we can even check the interval currently. And then if you check the balance, it should go down every single time. Now it's down to 1.5 HBAR. That's probably because it got executed and you spent all that HBAR already. So, and then there's also a function to stop scheduling. Let's go back here, one last thing. And here you see that the last transaction, it says, well, it failed. Why? Because insufficient pair balance, because we only sent 10 HBAR, and we ran out of HBAR pretty quickly because I'm executing it every 15 seconds. So you can see here, all of these are scheduled transactions that got executed. Eventually, it ran out of HBAR, and then it reverted. Now, if you wanted to reschedule it, all you have to do is top off this contract address, and then call the start scheduling function again, and then you can start the whole process one more time. But we're not going to do that. All right, let's see what else. I think that's part of the demo. Let's jump back to, oh yeah, one more thing. So I'm just going to quickly show a demo here. This is an entirely different contract. This is an ERC20 contract that has an airdrop functionality. So you can set it so that every 20 seconds, I'm going to mint X amount of tokens, and then I'm going to use the pseudo random number generator precompile to basically randomize and retrieve whatever address that is part of the registered list. And then it's going to mint it and then send the ERC20 token to that. And you can set it, you can look at the code later, but these are the kind of things that is possible, right? Like I'll quickly go ahead and execute this so we can see this in action. Where is it? All right, we need to first register for airdrop. So let me go ahead and register. All right, asking for MetaMask. I'm going to choose a different account after this. So we have two accounts. Just want to make sure I have the correct one. All right, so I'm going to register it one more time. All we're doing is registering for the airdrop. So we have two addresses, so we can quickly check it. Right here, get recipients, we have two addresses. And then we can see, okay, let's start the schedule here, start the airdrop. It's default values that I have set here, but let me do this every 15 seconds so we can quickly see it. Max 5 drops is after 5 times, it's going to basically stop. So these are the kind of logic that you can have, and I have an optional message. So let me just start the airdrop so we can see it in action. Who gets the airdrop? All right, let's go ahead and look over here. Oh, I should go to my other wallet, actually. Where is it? 5. Because I tried to call it from my other account that does not have access, because I'm going to show you something. If we look at the code, we are using ownable, and only the owner can start the airdrop right here, only owner. Let me go ahead and call it one more time. Start airdrop. We're just going to do 20 seconds. All right. That should be successful. There we go. All right, let's wait 15 seconds. It should go pretty quickly here. All right, let me refresh the page. There it is. Oh, wait, no. Is that the one?
Yep.
Yes, that is the one. So from to is the same, and we're calling it called execute airdrop. Let me go back and check who actually got the. Well, let me just check my own. Okay, this address got whatever 303. I can't make the number tokens airdropped. But this is the idea, right? These are the kind of things that is possible with scheduled service. So let's jump back to our presentation and end it. Let me go back to slideshow. All right, we saw the scheduling pattern. One last thing I wanted to mention, this is the entire flow, right? We deploy the contract, we call schedule message, initialization, the Hedera scheduled service stores it on the network, and then after 20 seconds or whatever time you give, the network will wake the smart contract, it'll call the smart contract contract will call itself, and then as part of the last thing that it does, it reschedules itself sometime in the future, in this case 20 seconds. So it just does that forever and ever and ever. And we didn't even need any kind of off-chain infrastructure. It was all done on-chain, possible directly at the protocol level, and this is magic. All right.
Okay. Thanks, Kiran, for that demo. So obviously we saw a few different options there, from something relatively simple, emitting a message, to something a little bit more complex with airdrops. So it kind of begs the question, is like, what can you build with it? I mean, right here we've kind of had 5 kind of general ideas of where it might kind of fall into useful use cases. So security, time lock multi-sigs, or dead man switches on contracts or functionality are really good use cases. In governance, token vesting, voting deadlines, and as we also said before, auto-executing proposals that can be a really good use of the schedule service. DeFi, lots of great use cases in there. Automated liquidations, auto-compounding yield distributions. Usually that's done through some kind of do work as people transact. It kind of piggybacks on, but you don't need to do that anymore. You can have a true yield happening at a certain time. Infrastructure, oracles are a great idea for this as well, and recurring payments. Some really good use cases. And then gaming, kind of as what we had that demo there, was like, scheduled NFT reveals, random drops, kind of it adds gamification into it as well, which are kind of really good use cases that using the Hedera schedule service and the random generator kind of together to create kind of compelling, use cases. So kind of trying to sum this up. So your competitive advantage using Hedera and being a developer, you can offer true automation on-chain, lower costs for each of your transactions and any of the tools that you kind of deploy. Higher reliability. It's a protocol level guarantee. It's stored on the consensus nodes and it's executed on there. There's no third party to kind of worry about for any kind of connectivity or kind of issues. Balanced with that as well, there's other zero infrastructure costs to you. So if you have a DApp or a project or that, you don't need to worry about infrastructure in AWS or DevOps to kind of have this thing working. And then also full transparency. Everything is visible on chain, so people know when things are going to happen, and you can see that and change that as and when you need. So Okay, you've obviously seen something today, and you can continue this journey and learn more. The tutorial that we had today is available at the link there. If you want to learn more about the HIP, the specification is available on the HIP site. And then the code repository for today is available from the QR code there on GitHub as well. Okay, yeah. So, thank you all for listening to us for 40 minutes. And thanks, Kiran, for such a great demo.
We have 5 minutes, so if we have any questions, we can take them. You can see the events, you just can't make anything out of it, right? It's not verified, so it doesn't know how to decode it. So.
Kiran, what was the question?
Oh, the question was, if the contract is not verified in Hashcan, can you see all that stuff that we see on Events tab? You can, you just see the events, you can't actually decode it. Sorry? The start button? Oh, that's also one of the things, yes. The contract needs to be verified. That's why I had the first demo where I could do it from the command line if it's not verified. If it's verified, I can also use Hashcan. And in the future, as mentioned in the earlier talk, we are working on an EVM Explorer, so that should be easier to navigate.
All good?
All right. That's it. Thank you, everyone.
Thank you, everyone. Thanks for your time.